Hey, good morning to everybody. Hope you're having a great day so far. Welcome to our Couchbase webcast today with Matthew Gross, DevRel engineer, who's going to kind of walk us through everything SQL for JSON. This is a bread and butter subject for us at Couchbase. It hits all of our groove, helps developers be more nimble in the types of applications that they are developing, and with AI and more talk about AI and developing AI applications. There's just more and more that's evolving in this space all the time. So today, the hot topics, of course, are SQL for JSON. We're going to delve a little bit into data modeling, and then hit vector search as well. If any of these topics are super resonating with you and you want a deeper dive, we would love to know. Put that in the chat. If it's something where we could do an entire session on data modeling, which we've done in the past, that would be amazing. Let us know what is interesting to you, and we'll try to put together another webcast for you. And with that, just a reminder, please use the chat. Great to see you all. Thanks for saying hello. And in the doc section, we do have a copy of today's presentation if you'd like to take that along. And then please do stay up to date with us. We have another webcast in 2 weeks where we're going to cover AI and AI services specifically. That's March 11 and 12. And that's going to be with Mark Gamble on our team. That's going to be a really great session as well. So we hope to see you there. And with that, I will kick it off to Matthew Gross. Thank you, Matthew.
Thank you very much, Suzanne, and thank you everybody who's joining in the chat there. Just to repeat, Suzanne, if you've got questions, you can throw them in the Q&A window right there, and I'll get to those at the end. If we have enough time for all those, we'll get to all your questions, but we will eventually get to them, even if I can't cover them today. So just throw a question in there, and we'll address those at the end. So we're going to talk about SQL for JSON today, and some of the ways that SQL in Couchbase allows you to simplify your data access across multiple models. So this will be a lot of fundamental stuff about SQL, but we're going to get into the cross-model, multi-purpose nature of Couchbase here a lot today. So if you're like most developers, and I know I am, you probably already know how to write SQL. And even if you only have a passing familiarity, this, I think, is relatively easy to read. You understand what this means. Find inventory items with quantity below 10 or above 50. It's either on sale or it's less than $5. I think that's pretty readable. SQL is designed to be English readable language. That's its whole purpose in the first place. So I like that quite a bit. Now, this is a screenshot from the documentation of a popular NoSQL document database. And this query here returns the same results. But I would argue that it's harder to read, harder to write, and there's fewer people in the world who can do it compared to SQL. But I mean, in the NoSQL world, what choice do I have? I want the benefits of NoSQL, so I have to learn this kind of approach. And I'm going to, of course, make the point that no, you don't. You can apply your SQL skills to a NoSQL database. So this is what we're going to cover today. We'll talk about, thinking about relational data in terms of JSON data modeling, how that might work, similarities and differences there. The basics of SQL++. We're not going to go deep into all the syntax, but we'll cover a few things. Then I want to talk about AI, vector search, hybrid search, and just kind of multi-model data access that you can do in SQL++. And I've got a fun demo to show off as well, a demo that I built, and I really enjoy showing it to people. So we'll get to that. And then, of course, Q&A at the end if we got time. All right, so relational data to JSON. So we don't necessarily want to migrate. We don't necessarily have to migrate, but I think it's useful to think about, the most common data model relational approach that people are familiar with and build from there. So this is a model of a small relational database tables for customers. So there's a customer table, it has name, ID number, whatever. Billing table has payment methods, billing address, things like that. Contact table might include addresses, email, phones, whatever. And that might be 3 or more tables, in fact. Purchases as a list of items that customer purchased, their history, date of purchase, things like that. And then connections, this might be relations to other customers for like a streaming service that has multiple users on the same account, that kind of thing, or social media, maybe, whatever. Now, relational is very popular, so I'm not going to get into all the benefits of relational, but what are the drawbacks of the relational approach? Why would we want to consider something else in the first place? So I think we can really classify it as 4 different things that might make you want to, rethink whether relational is the right fit for your project. So uh, first one is scaling. The number of users increases, so do the demands on the database. And the legacy relational databases are designed to scale vertically, but that can get very expensive, and there can be a ceiling as well. Horizontal scaling, I'm not going to say it's impossible with relational, but introducing sharding to a relational database is a very difficult and complex type of thing to pull off. It can be done, but it's a lot of extra work. Flexibility, so making schema changes to relational databases can be painful and can even cause downtime in some situations. And you're also limited to one form of data access. You can only use SQL to query and interact with data. That's the only option you have. Performance is another one. So again, the legacy relational databases, they have their roots in the days of hundreds of users, not hundreds of thousands or millions like a modern website would use. So data being flat and complex, entities modeled with multiple tables, that means a lot of joins, which could mean slower performance. Availability is the last one. So typical legacy deployment is one server. So that can be like a single point of failure. And again, you can configure replication servers. It's not impossible, but with the constraints on relational data, this can result in a performance hit, depending on your SLA, things like that. So these are the reasons that a NoSQL, a JSON document database are considered, right? Or possibly used in conjunction with a relational database, not necessarily to replace, but maybe to supplement. In a JSON document database, the data can be more centered on the root data. So our root entity is kind of the customer, and all those other satellites were just part of the customer. And so inside that JSON document, the associated data can be represented as arrays and objects and nested objects and so on. And each document has its own self-described schema. When the data structure needs to change, a developer can add a new field to their class in their code, and that's going to be saved to the document. I don't have to make any changes to the database itself. So you can closely map your data objects to what's actually stored in the database. So we've actually, Suzanne mentioned, we've done a full data modeling webcast before. So I'm not going to go into that in much detail today, but just as a side-by-side, the model on the left is more of your traditional relational model, at least 5 tables, probably more, lots of joins, potentially lots of overhead for things like ORMs, if you want to use something like that. ACID transactions, a lot of ACID transactions are necessary to interact with this data because it's so split up. Lots of schema to carefully manage and change. Some organizations, some teams, if you just want to add a column or make a change to a column, like I want to make it from varchar 40 to varchar 50. Some organizations, that can be like a 2-week process, with lots of review and approval and things like that. And with JSON, it's not that complicated. So on the right, we've got a single JSON document that represents everything on the left side. But I can get that whole document with one get operation. I don't have to use SQL. I can use one get to get the entire customer. And I can store a complex set of data with arrays and nested objects. And JSON can be serialized and deserialized to from objects in code directly. No need for that additional ORM overhead there. But I did mention there are some good things about relational databases that developers really like. And so these are 3 that developers really care about, right? So one is SQL. It's the most popular data query language just across the board. Lots of training material. It's taught in schools. I learned SQL in college. It has concise declarative syntax, like I mentioned, easy to read. Joins are important, right? So the model I showed you in the last slide, everything was combined into one document. That's not always possible, of course. So what if I can't get everything from one document? What if I need to join 2 or more documents together? And then finally, ACID transactions. Again, if your data is split up in relational databases, you need ACID transactions. But in the situations where you can't combine it, or it doesn't make sense to combine it, you still want to have an ACID transaction so that you can make changes. For instance, the bank accounts, transferring money between two bank account documents. You can't really do that without an ACID transaction. So those things are all critical, and those are things that developers really will notice when they're not around in a NoSQL database. So let's introduce SQL++. So also known as SQL for JSON. This is a semi-structured query language that encompasses both SQL standard and the JSON data model, and it's SQL backwards compatible. And this was actually first proposed in an academic paper back in UC San Diego years ago. Couchbase was the first to do a commercial implementation of it. And there's some other document databases that have added at least a partial implementation of SQL for JSON. So Particle is for DynamoDB. Cosmos DB has a small amount of SQL. Apache Ignite, it's not exactly a document database, but it does have it is NoSQL, and it has a full SQL support there. And it's also worth pointing out that this link on the right here, this right-hand side, this is a book written by Don Chamberlain. He's one of the inventors of SQL, actually. He's written a book about SQL++, and you can actually get that on Amazon, or you can get a free copy of this link right here if you want to check out that book. I'd recommend checking it out. Again, one of the fathers of SQL, writing about SQL++. So I'm going to take you through the basics of SQL now and touch on joins and acids along the way. Joins and acid, not acids. Let's start with this little translation guide here. It's a list of terms that if you're familiar with the relational world, you are probably aware of. I'm using SQL Server as an example, but similar concepts in Oracle and Postgres and MySQL. And this is how they translate over the NoSQL JSON document database world. And again, I'm using Couchbase as the example here. But yeah, similar mapping with MySQL, Oracle, Postgres, Cosmos, etc. This is very much simplification, right? There's lots more detail to it. It's not just different names for the same thing, but this is a pretty good starting point, a baseline for getting started about thinking about how Couchbase data structures work. So just as an example, in SQL Server, you have a table, right? Always working with tables. Couchbase, the closest concept to that would be a collection, right? So a collection contains lots of JSON documents. A table contains lots of rows. Of course, the main difference here is that when you define a table, you have to define, okay, here's my columns, here's the data types, etc. For a collection, you just basically give it a name, and that's going to contain JSON documents, whatever JSON documents you want to put in there. But typically, they'd be, related to each other in the same way that a row in a table is related to another row in a table. Okay, so the basics. Let's get into this. I'm going to assume you have some familiarity already. If you don't, that's okay. Just the important thing to know is that SQL is very popular. SQL is used by pretty much everybody, not just developers, but DBAs, even non-technical roles. One of my first jobs was at a business office where I was brought in to work with the databases, the SQL and whatnot. But many of the accountants there were mildly comfortable with writing SQL. So what I hope to show here is that SQL++ is not very different from SQL at all, and it still allows the developer to get the flexibility of JSON data. So before I show you any actual SQL++ queries, I want to have some data to show you that's going to actually, help you understand how we're querying this. So this is some airline data. This is a sample data set built into Couchbase. If you sign up for a Couchbase Capella account, which is free, by the way, this will be some of the sample data that's in there already. This is a sample route document. This exists in a collection called route, which again is kind of like a table. Each document has a key. The key for this document is route 5966. In the JSON, notice it has a source and destination. Notice it also has an airline ID field, which is kind of like a foreign key, but it's not a relational database, so this is not a constraint or nothing enforced by the database. There's also a schedule field, which is an array. In relational, this would typically be 3 rows in another table, but in this case, it's denormalized into a single document. Okay, and then, so I mentioned the airline ID over here. There's also an airline collection. This is a sample document from airline collection. This is very flat data here. So this is very much like a row of SQL data. There's no arrays or objects or anything, but it does contain the name of the airline, which is not in the route document. So hopefully you see where I'm going with this. So let's get into some SQL then. Let's try a basic select query here. If you used SQL before, I'd say this is pretty much exactly how it would look. If you're on a relational database, there's no difference at all between SQL and SQL++ at this point. It is backwards compatible after all. The result of this query would be something like this. So this is the first difference we're going to see. It's JSON data, not rows and columns. It's an array of JSON objects. But otherwise, it should be feeling and looking pretty familiar. Now, we got results. We got a source, destination, airport, and we've got an airline ID. So it's not quite ready to show to our human. We're building a web page or a travel site or whatever. We've got airline ID, but we need the name of the airport. So how do we get the airline name? So this is where we get some more modeling discussion. In a relational database, there's really only one approach, and that's use a join. In a document database, this becomes a modeling decision. One option is to add the airline name directly to the route object. Now, this would be frowned upon in a relational database because it's duplication of data. Now, you could do it, but typically you want to keep things in third normal form in a relational database. But with this approach, the JSON approach, there are some benefits. It eliminates the need for a join. So this makes the data access faster, and it improves human readability. So I can see that the airline name is right there in the document. The trade-offs, though, is that it takes up more space. Now, that's not really a big deal anymore. We've got really huge hard drives these days, and relational databases were designed when hard drive space and memory was highly constrained. Duplicated data opens the door for data to be inconsistent. I think this is probably the biggest concern. What happens if Delta changes their name, for instance? Well, then I've got to change that name in all these other route documents. But this kind of trade-off would be worth it if an airline name hardly ever changes, right? If Delta changes their name every 20 years or so, it's still worth it for the performance trade-off, the reduction of joins. All right, so this is kind of the classic NoSQL approach. Is we don't have joins, so we just put all the data together in one document. We denormalize and duplicate data. However, let's say the data you're joining to does change often, or it just isn't a good idea to embed it. With SQL++, you can use a join. So we have an inner join, left join, right join, just like in a relational database. And this is how a join would work between route and airline to get the airline name. So most of this should be, again, pretty familiar to you if you use SQL, except for that there's one line there that you might be a little bit curious about, and that's that meta keyword. So remember that in Couchbase, each document has an ID. That ID is technically not data. It's not in the JSON. It's metadata. And so this meta function in SQL++ gets the document ID. And there's some other things it can get, but mainly the ID. So the results would look like this. So just by joining, we can see that airline 137 is Air France. Now, a join is still overhead here, just like relational. But with this flexible approach to modeling, where you can sometimes embed, you can almost always reduce the amount of joins that a query needs and get better performance. Now, I did mention Cosmos and Dynamo earlier. They do not support joins between documents like this. So this is something that's Couchbase is relatively, unique in that they've been doing this joins for a long time, but Cosmos, Dynamo, they don't support those yet. Okay, let's get a little more complex. This is a select with a join and a having and an order. So this is, the point I'm trying to make here is that this is SQL++ is a very mature standard implementation. It doesn't just look like SQL, it is full SQL. So I want to know which airlines are the biggest, which have the most routes. Using an aggregate function here, that's count with a group by, and then qualifying the aggregate result with a having to restrict this to just the biggest airlines, and then order by the count in descending order. This kind of query in SQL is very concise and readable. And with SQL++, you can run it on JSON and get results like this. So don't know if this is actually accurate, but here's the two biggest airlines in the sample data. Now, this kind of query, you could do in non-standard, non-SQL languages, yes, but it would be, I think, a lot harder to read and write and reason about. Just maybe it's personal preference, but I really like being able to look at the query, glance at it, and understand what it's doing and how I can make changes to it. Okay, so that's about all we're going to get to in terms of query, like select and CRUD queries. But I want to show some other features of SQL++. So this is ACID transactions. I got two different accounts, two different bank accounts. It's the classic example. Each one has a balance. I want to transfer an amount from one to the other. That means a debit from Matthew, a credit to Emma. Both debit and credit have to happen, or else neither should happen, right? You can't have halfway, because otherwise you're creating or destroying money, and you don't want to do that. So this is not possible without an ACID transaction. So there's multiple ways to do an ACID transaction in Couchbase, but within SQL, there's a begin, commit, and rollback syntax, just like you would expect in SQL. Save point is also there. There's no rollback in this example, but rollback and save point, they're all part of SQL language. One main difference to note is that this is a distributed transaction. So in Couchbase, you have multiple nodes in a cluster, multiple servers. So customer 1924 and customer 4872, they don't have to be on the same machine in a cluster. They don't have to be on the same shard. They don't have to have any relation to each other. They could be completely two different machines in the cluster. And so that means we've got two documents over two different machines. We have to communicate and orchestrate that ACID transaction across the network. So that means that this comes with some more overhead. Transactions need to coordinate. So I would recommend avoid ACID transactions and replace them with modeling decisions if you can, but they are here when you need them. Okay, indexing is an important part of SQL queries. This syntax here is very similar to relational. So this first one is a primary index. Notice I'm not specifying any fields there. I'm just saying create primary index on, and those three tokens there, that's bucket, scope, collection. So you kind of refer back to that translation document. It's kind of like database, schema, table. But a primary index will enable queries to scan all documents in that route collection. So right there, bucket, scope, collection. Now, travel sample is the bucket name, inventory scope name. Yeah, I already covered this. The first index here, this primary index, is not great for production. Any query that uses it will be scanning every document in that collection. It's kind of like a full table scan. It's good for development, though, and maybe some edge cases, but you really want to try to stick to indexes that are more like the second example here. So this is more like a production level index. It's an index on the same route collection, bucket scope collection, but I'm only indexing the source airport field. And I can also put expressions in here if you wanted to. Any query that's filtering on source airport could use this index. So it's going to get a faster result than scanning every single document. Now, as in the relational world, indexing is a very deep topic and something of an art form to get right. But fortunately, there's an index advisor built into Couchbase Server and Couchbase Capella that can make recommendations for indexes based on your query. So this is a screenshot of the Capella query workbench. Might be a little difficult to read depending on the resolution of your screen there, but I've entered a query here for airline routes on the left-hand side, this one right here. And when I execute that query, results show at the bottom. On the right-hand panel, there's an index advice section. And these are the recommended queries to speed up the query. Recommended indexes to speed up the query. Of course, you shouldn't just blindly add indexes. This won't always give you the best index for pure performance, right? But especially for complex queries, this tool gives you a great place to start. Okay, next, cost-based optimization. So this is, I cover this because sometimes I get questions about, how are the indexes optimized, chosen, that sort of thing. So let's say you eventually have a ton of indexes, right? This is kind of a weird example, but maybe these indexes all made sense at some point to have them in different orders, especially if you're using what's called a rule-based optimizer, right? With rule-based optimization, putting the expressions in a certain order can lead to better performance. I remember having to do this a long time ago with MySQL. I had a certain query that joined, and I just changed the order of the fields, and I got better performance instantly because it was using a rule-based optimizer. But now suppose I want to run this query right here. Which indexes should be used? And so this is my favorite answer of all. It depends. It depends on what's called the data cardinality of each field involved in the query. So if there's 5 different zip codes in the system, or 5 million. It makes a difference which order we're going to go in. Is there 5 million mats or just 5, right? How many different names are there in the system? How many different statuses are there? That sort of thing. And with JSON data, it gets even crazier because it's possible that zip is a string in some documents, a number in others, an object in others, and so on. Now, hopefully you're not doing that on purpose, but it is a possibility with JSON data. So a cost-based optimizer is going to take statistics about cardinality into account when choosing a query plan. So if you're deep into relational databases, you're already familiar with update statistics, and that's also here in SQL++. Another feature of SQL++ is user-defined functions. This is a simple example here of a function that returns a set that matches a simple criteria. So this is just based on locations that are eat, or maybe they're hotel or something like that, right? And then so from that function, you could use that in a from, for instance, here, the bottom there, from locations. You can also create scalar functions that for compute or for filtering, that sort of thing. But you can create them with create function syntax. I think I might be missing a bracket. No, I'm not missing a bracket. It was hiding there at the last line. But yeah, create function for user-defined functions in SQL++. Okay, before I move on to some AI and vector and hybrid search, I just want to mention, because I get questions about it all the time, like how do I actually get my data into Couchbase so I can query with SQL++? And so the usual tools for moving data around still apply. You can build an ETL, set up a Kafka pipeline, do a command line, import, export, that sort of thing. But I want to point out 2 specialized tools that you could check out if you want to move data from another database into a SQL++ database like Couchbase. So these can not only just move data, but they can also remodel the data in the process. So they can take that very flat fragments in relational data and remodel them into more consolidated JSON objects. And so that's one cool thing that these tools can help you do is just change the modeling to make it more efficient for JSON, if you want to. Okay, now on to AI, vector, and hybrid search in general. So I want to set the stage a little bit, thinking about enterprises, large teams, companies. As applications there and requirements, applications grow, as requirements grow, architecture can start to look like this diagram. This might be a little bit of an extreme example, but maybe the team starts with a relational database like Oracle. And then there's a requirement for text search. So, okay, now we'll add Elasticsearch to the equation. So we use Elasticsearch for text search and Oracle for normal queries. Then we're going to add Redis to improve performance with caching. So now we have Redis, Oracle, and Elasticsearch. Then maybe we bring in Mongo because we want some flexible JSON requirements to our product catalog. So now we have Mongo, Oracle, Redis, Elasticsearch. And now, of course, these days, everyone's got to add AI and RAG to everything. So we bring in Pinecone for vector search. So now we have Redis, Mongo, Oracle, Pinecone, Elasticsearch. So now we have an architecture where we have 5 different SDKs and 5 different tools. All these tools need to be upgraded, patched, licensed, deployed, supported, integrated. And all those lines in between, you can kind of see up here, all these lines in between, because we need to move data in between those databases, right? All those lines potentially adds even more tools that need to be upgraded, patched, licensed, deployed, etc. So this is kind of the issue we call data sprawl around here. So with Couchbase, our data platform is designed to help you reduce data sprawl. So we want to have a lot of those capabilities built in and allow developers to support many different functional requirements in a single data platform, reducing those sprawl headaches in one database instead to upgrade and manage instead of multiple. And the other great thing is that it's a single pool of data now. So that single pool of data, that one copy of data, I can interact with Couchbase via a number of different APIs in a single SDK. So I can do, for key value here, I can do get and put operations, really simple, straightforward operations. For text search, there's an API very similar to Lucene called full text search, and that includes geospatial. You'll see that today in the demo. SQL++, you can execute literal strings of SQL from your code. For time series, there's specialized functions that can operate on specially formatted JSON data for time series operations. For graph traversal, we've got something called recursive CTEs. It's not exactly a graph-based language, but it can help you do graph-based operations like hierarchies and parent-child relationships. So what's it got to do with SQL++? Well, just to walk you through some examples here, here's what a key value lookup would appear to look like during while using the SDK. So this is a .NET example, but it's very similar in other languages. You can do this from code, or you can just do use keys syntax in SQL++ to do a key-based operation. Now, in general, using the SDK here will be faster because with a query, I have to go through query parsing, overhead, maybe some indexing, things like that. But if you need flexibility to combine a key lookup with other access methods, use a SQL query. So for instance, a text search. So the top one, again, C# example, SDK to do a text search for, I want a restaurant that's offers breakfast, but it's not crowded. So I can do that, or I can do it in SQL with the search function. Again, just kind of the specially formatted Lucene type of a search string there. And this full text engine is also where you do geospatial queries to find items by latitude, longitude. Time series is also possible in SQL++. JSON must be in a specific format, but once it's there, there's a time series function available in SQL++. And there's no time series specific API in the Couchbase SDKs, but certainly you'll rely on the SDK to help you properly format the JSON in the first place. And then vector search is the last one here we'll talk about. This is a fundamental tool for working with AI models like LLMs, working with RAG, and so on. So again, you can do a vector search from the SDK against a particular index. That's what this top code is here. Of course, you could also use something like LangChain or a Llama index or whatever to do that in code. But you can also, in SQL++, use the search function, which supports a vector search. So right there, you can see the search function and KNN, which is the nearest neighbor. How many neighbors do I want? What field am I indexing? Or what field are my vectors in? And then what's the vector I want to match those to? So I'm going to show this actually in the demo as well, along with SQL and geospatial all together, so you can see them in action. One more note about AI, just quickly here. You can certainly use Couchbase to perform vector search. That can help you, augment data to LLMs for RAG, that sort of thing. But Capella is also on the consuming side of AI. Capella has a built-in AI chat called Capella IQ that can help you read, write, understand SQL++ queries. So it's still kind of early days for it, but it's great for developers who are just getting started with Couchbase. This example here takes a English description of the data that I want to query, and it generates a SQL++ query that can be executed, copied, charted, favorited, iterated on. So that's a nice little tool built in there. So if you're not super comfortable with SQL just yet, this will help you start to write some SQL queries pretty quickly. Okay, so this all sounds great. How do I get started? How do I start writing SQL queries? So I mentioned this earlier, Couchbase Capella. This is Couchbase as a service. There is a completely free tier available. It's not necessarily production ready. It has 8 gig of storage and it's limited to one node. But all the stuff I've shown you today, SQL++, UDFs, geospatial, full text search, vector search, everything like that is scopes and collections. That's all available in the free version. And also mobile app services as well are available there. So if you're working on a mobile app, I didn't even discuss that today, but that's also available in the free tier there. And as I mentioned as well, the travel data that I've shown is already loaded when you create your free tier account. And you can also connect to this free tier using the SDK of your choice. So .NET, Java, Node, Ruby, whatever. You can connect to this and start writing your application. Once you sign into Capella, there's also something called a Playground. This is interactive tutorial where you can run these queries right in your browser. And one of the tutorials is specifically for SQL++. And you can make tweaks along the way as you want to see what happens. So just click the Playground link at the top right after you log in and create your account. Okay, so now it's time to switch over to the demo. Just in advance, if you're interested in checking out the code for this and running it yourself, You can find it on GitHub there. That's GitHub mgroves. What is this thing is the name of the demo application. So let's switch over there. I've got it running here locally on my computer. I also got a Couchbase running locally, but of course this will work fine with a Couchbase Capella. What is this thing? It's basically a demo e-commerce type of app. So if we go to stores here, you can see I've got some physical locations in the system that are loaded there. And so each of these stores is just a latitude, longitude, point, and a name, like that. And so each store can have items in stock is kind of the idea here, or they might have item out of stock, that sort of thing. Go over to the browse catalog. These are all the items that are potentially available for me to buy from the e-commerce site. So I've got some Couchbase swag here. You can see that one of the things I've already done is given it my location permission. So it knows my latitude, longitude via the browser. And so then it can say, well, this Couchbase pen there's not a location nearby you that has this in stock. So this is delivery only. But if I go down to here, the cryogenic coupler, you can see that there's 3 stores close to me. 2 of them have the cryogenic coupler in stock. So what I'm doing here is I'm combining SQL and geospatial into one SQL query. And I can also do some filtering. So I want items that are no more than $5 in price. So maximum of $5. It filters it just down to those items. And I want items that are only 5 stars or above. So there's just 4 items. Now, one of the cool things about this demo that I really like to show off is this button up here, this top right button, SQL++. If I click on this, it will show the SQL that was put together to actually get these results. So it's got some comments as well, so you can kind of break it down a little bit. But this is a relatively complex SQL query that is doing all this for me. So we've got the CTE here. I don't think I mentioned that, actually. You can certainly have CTEs in SQL++, common table expressions. And then inside the CTE, it's using the search function to do a geospatial query, stores that are within 15-mile radius, and organize them by how close they are, and just get 3 of those. Then I've got this just regular plain old SQL++ select query here with a subquery, and that's going to join together on those document keys to find what's actually in stock in those nearby locations. And then I've got some filtering here. So this is, remember I said the price less than equal to $5, rating greater than equal to 5. And then paging down here, of course, we got to order it by something to do paging. So we've got order, and then a limit offset is how you do paging in Couchbase. So here, that's probably, I think it's the same way Oracle does it, MySQL, maybe Postgres, something like that. But yeah, that's how you do paging in SQL++. And you can copy this if you want to, and then paste it right into your query workbench in Capella if you want to. And then you can start to tweak it and play with it and learn more about it. Okay, so I said I would show it with vector search a little bit. So that's the main point of this site. It's called What Is This Thing? So true story, I actually own an ice cream shop. And one of the things I have to do a lot is when stuff breaks, which is way too often. When equipment breaks at the ice cream shop, I need to figure out how to get it fixed. Sometimes I can just order a part and fix it myself. But I'm relatively new to the business. I don't know what everything's called just yet. So sometimes a part breaks or falls off a machine and I don't know what it is. So I thought it would be nice if I could just take a picture of it and use like a image vector, an image embedding, I should say, to figure out what the item actually is. And that was the idea with this demo here. So each one of these items in the catalog has an image, and each of those images has been run through an AI model that will generate a vector. And then I can upload another image, which will also get a vector. So let's say I'll go with this pen here. This is kind of a generic pen. Here, I'll show you the close-up of this. This is an image I took of a pen on my desk. And that pen is not exactly in the system, but there is a Couchbase pen in the system. So visually, they're very close. So you can see that our vector query has come a pretty close match. And there's a couple other items that are not as good at match, but they are, similar enough visually that they might be the next closest neighbors. And if I see pickup options, again, this is going to use geospatial to figure out if this is in stock nearby. And it's not, so I'll add this to the cart. And again, we can see the underlying SQL for this. So again, the CTE with the closest stores, the regular SQL with subquery, but here is the vector search portion, the search function, the k nearest neighbors, so 4 near neighbors, and here's the vector of the image I just uploaded. This was run through Azure Computer Vision, actually. It doesn't really matter. As long as it's a vector, using the same model, this will be fine. So this is the vector of the image I uploaded, the generic pen, and there you go. I can copy this into Capella if I want to, but the results are, here's the most likely match, the nearest neighbor, and here's the related items. So in this one SQL query, I'm doing geospatial, I'm doing SQL joins, I'm doing key value operations, I'm doing a vector search. If I wanted to, I could add in some time series here. I'm not sure exactly why I need to do that, but I could. I could put in some text querying, some more filtering if I wanted to. It could all be done in one single query. Instead of having to pull in data from 5 different data sources in our data sprawl, it's just one query, one platform, one pool of data. Okay, so again, if you want to check that out, it's available on GitHub. mgrows, what is this thing? There's some instructions there for how to get started with it. And certainly you can reach out to me if you have any questions or any trouble getting that to work. But that's it for today. If you want to contact me, you can find me on X, on my email there, on LinkedIn, and so on. And at this point, I'm going to go check out the Q&A here and see if there's anything interesting to check out. Okay. All right, so I'm seeing a question here. What about using declarative logic to define SQL data integration? And that's from Grant. I'm not quite sure the context of that question, Grant. To define SQL data integration. Yeah, I need a little more specifics there. I'm not quite sure where you're going with that. So I'm all about declarative logic. SQL itself is a very declarative language. So what else we got? We got a lot of Canadians in the channel still. Okay, so while you're thinking of your questions, to type in there, put them in the QA box or in the chat box. Either one's fine. Okay, here's another question. Does SQL plus or Couchbase support stored procedures? So I showed you user-defined functions, the UDFs. So in a sense, that's kind of like some things that stored procedures do, you can accomplish with the UDF. One thing I didn't show you in this presentation, it's not in the free Capella tier just yet, but it's certainly available in full version of Capella and Couchbase server. It's something called the eventing service. And the eventing service allows you to write JavaScript functions that respond to data mutations. So if a document is created, a document is updated, a document is deleted, you can write some custom code to respond to that event. So that's something that might be able to take the place of some stored procedures. So yes, you could do that. The demo link to GitHub, yeah, I'll put it back on the screen here. There it is right there. github.com/mgroves/what is this thing. I don't know if Suzanne, if you got that in the documents or not, but if you want to throw it in there real quick, you can certainly do that. But I think also the full slide deck will be available if you hit the Docs tab there, and you can of course download the whole presentation and get the links from there. See, one more question. Oh, here's another question. Are there any plans to increase the size of the JSON document from 20, I assume that's supposed to be megabytes, not milligrams, but yeah, so what Jeff is talking about is that Couchbase document size is limited to 20 megabytes, which is actually a pretty high limit compared to other document databases. I think Cosmos is like a 2 megabyte limit and Mongo is like a 6, something like that. I don't know. I don't think there are any plans to increase the size limit. One of the problems with having a bigger document size. This is kind of an art form to figure out what's the sweet spot for document size, because as I mentioned, Couchbase is distributed, and so when you have replication turned on, you've got to copy documents to other nodes in the cluster, and if those documents are really, really large, that's really going to put a lot of strain on the network and the servers to move that much data around. So I think it's something that could be increased. Certainly, like there's nothing preventing that from happening in the code base, but I think that's just kind of the reasonable upper limit, and still allowing replication and things to still occur. So I would question, what is your use case where you need bigger than 20 megabyte documents? If you're trying to store files or binaries, I don't know if Couchbase is necessarily the right choice for that, especially larger binaries. We do have customers that do that. They split up their binaries into multiple documents and piece them together, but it's not something I'd necessarily recommend as a great use case for Couchbase. That's something I would say more like an S3 bucket or a file system would be better for that. Do get that question a lot. Let's see. Oh, another question about 20 megabyte limits. What are the recommended strategies for handling situation limit of 20 megabytes? Say from the example of purchases, including the document, number of purchases continues to increase, that increases the size of the document. Yes, right. So if you have a situation where it's unbounded like that, so first of all, I will say 20 megabytes can store quite a lot of text data and JSON data. You could put quite a lot of purchases in there and not hit that 20 megabyte limit for a long time. But that being said, something like maybe a social media app where people are posting updates and, over the years, they're posting hundreds or thousands of updates. Probably don't want to put that into a single document. So my guess is, my advice is, I guess, think about, what truly is the most amount of data you're going to put in that purchases array or whatever array, and just do an analysis to figure out how many you can fit into a single document. I'll bet you'll be surprised at how many you could actually fit of purchases data. The other option is you could put you could have purchase information in a separate document and just store the ID in a purchases array. You could also put the purchases into their own documents if you really want to go that way and go the full relational approach to it. That's totally doable in Couchbase. Again, it just depends on your use cases, what you're trying to query, how often you're trying to query it. But the thing with JSON data and the thing with how Couchbase works is you have multiple options. With relational, you really only have the one way, the one approach. With JSON, you can do lots of different hybrid approaches, relational approaches, embedded, denormalized approaches. Okay, let me just look at these chat questions for one more thing. Okay, I think that's all we have, Suzanne, in terms of questions. Oh, I think you're muted there, Suzanne.
Sorry about that. I needed to come back on. Hey, thank you so much, Matthew. I think this was a really great session. I think there was kind of a comment in the chat about using other tools. I mean, I think part of what we're trying to get to here at Couchbase is we're trying to create a unified developer platform, right? So that everything that you need is within our platform, that you don't need to necessarily go, outside and find, different code using ChatGPT or using other such things. We're working on a platform where everything's going to be kind of built into one system, and we continuously make improvements in that way. So again, I want to thank everybody for coming. Hopefully you can come and hear about our AI services. That's also going to kind of touch on this unified developer platform that I just mentioned. That should also be an awesome session. Hope to see a lot of you there. And again, thank you, Matthew Groves, for your time today. And we'll see you again soon. Thanks so much. Bye.